given the function, given that f of c equals 10, first part says use the intermediate value theorem to show that there is a number c such that f of c equals 10. Okay, so if I go back to the theorem and I break things down, first part of this theorem, if I'm going to use it, we have to establish that the function is continuous on our interval a to b. Now, we don't have a specified interval here, do we? So as far as we're concerned, our interval is all real numbers. Can we conclude that this function is continuous for all real numbers? Well, yes, we can, because this function is a polynomial function, and the domain is all real numbers. So we start by saying f is continuous on, if there's a given interval, you use that, but in this case there is not, so we'll say all real numbers. And normally the way these problems are set up, if there's a given interval, it's going to be continuous. If there's not a given interval, then we're just going to say it's continuous for all real numbers. Don't overcomplicate things there. All right, next part. As we go back to the theorem, and this is where the calculator comes in handy. N is any number between f of a and f of b. Okay, f of a and f of b are kind of vague for us right now because we're talking about all real numbers. And there's no way we can take this infinite concept and just plug in the function, right? So let's focus our attention in on the fact that n is 10. And let's see if we can find some numbers for x that we could plug in and get reasonably close to 10. So what we're trying to do here basically is we're trying to surround that value. So this is what I do. I go to my calculator. For y equals, clear that out. I'm going to plug in the function. And since we've been using our table a lot lately to plug in values, it should be set up for this. If I go to the table, I'm working with all real numbers, which is pretty large, but let's start taking some values here and see if we can narrow this down to where our y column here starts to surround the value of 10. So I pick a number. I pick 0. I plug in. Now let's see how I did. I get 0 back. 0 is less than 10. So let's take 1. Work my way up. Okay, I got 1 back. That's less than 10. Let's take 2. Work my way up. Okay, now I'm getting closer to 10, right? So if I choose 3 now, whoa, went well past 10. But the thing is, I've found 2 x values here. X is 2, x is 3, where if I plug that into the function, I get a couple of values that surround 10. So I'd like to be able to plug in a couple x values where I get one value of the function back that's below the n, which in this case is 10, and one where I plug in, I get a value back that is larger than that n value of 10. So how I summarize now, I say that f of 2 equals 6, and f of 3 equals 21, right? Why that is relevant? I say so f of 2, since that was 6, is less than the value of 10 in question here, which is less than f of 3 because that's 21, right? 10 falls between those two ideas. That's basically what I'm stating right there. So I go back to the theorem now. What have I covered? I've covered that the function is continuous. I covered that there is this value 10 that is between f of a and f of b. I've even established what a and b are. So there exists a number c on this interval a to b. That's good news. Now that we've done this middle part, we can actually go forward with the process and figure out what c is. So we conclude now our formal presentation, that is part A, by saying, therefore, by the IVT, our intermediate value theorem, there exists use a backwards E there, our mathematical notation if you'd like. There exists a number C on the interval 2 to 3. Remember, interval was not given in the first place. We had to narrow down the search. And once we found that we plug in 2, we plug in 3, we get values that surround that 10, then we go to an interval of 2 to 3. All right, for part B, the question is, use your calculator to find C. So here's what we're going to do. We know that f of C equals 10. We also know that C is going to fall between 2 and 3 when we actually find what C is. So I start down here by saying that f of C is equal to, now let's see, my function is defined as x cubed minus x squared plus x. So I'm going to insert C in all these x positions and say f of C equals c cubed minus c squared plus c. Now I know f of c is 10, so I'm going to plug that in and say 10 equals c cubed minus c squared plus c. And I appreciate at this point my goal is to solve for c. The question is, with this equation, how am I going to do that? Well, let's see. We got a lot of c terms, so maybe it might be a good idea to move that 10 over. Normally, when we set things equal to 0, there's a way somehow to solve this. So subtract 10 over. As I look at that, I got 4 terms. 4 terms, usually I think factoring by grouping, but that's not going to work. But I am prompted in the instructions here to use my calculator, right? So there must be some way to relate to the calculator. What you do, if you go to y equals now, right now in y equals, we've got the original function, which is kind of close to what I have here set equal to 0. But if I tack on that minus 10, so basically take what is set equal to 0, let that be your function now. Let's see if we can figure out our solution here that's supposed to be between 2 and 3 by looking at the graph. All right, looking at the graph. Hey, there's good news. As I look at this graph, I see that this graph passes through the x-axis between, of all values, 2 and 3. How about that? Now, if this is being treated as my function, over here, this is my function value of 0. That means my y value would be 0. I'm trying to find the x-intercept. I'd like to know where this is crossing the x-axis. So how I do that? I hit second, and I hit trace. You are trying to find the 0. So you go to number 2. You're prompted with these questions. Remember, you're trying to zoom in on this part right here. So the first question is left bound. What you're going to do is you're going to take little Frogger guy here. You're going to move him over. You're going to get closer to that value you're trying to find, but you're going to stay to the left of it, since this is the left boundary. And once you're to the left of it, hit enter. Now we're going to go to the right side of this, so we're going to go past that point we're trying to find. We are now to the right of that point. Hit enter. Okay, we're not going to guess. We're just going to enter one more time and watch what happens. It gives us that intercept point. So if we round off, let's say, to 3 decimal points, 2.365 would be the x value as our intercept here. So 2.365, we go back here, c equals 2.365. Part B, we were supposed to use the calculator to find c. There you go. We found C. All brought to us by the Intermediate Value Theorem.